Well, I'm going to record a video for you on the second side of this operation. So this is the part we're finishing up. We've already roughed it over here. Now we'll flip it over, blow the chips out. Load it into our soft jaws. Make sure it's good and snug. Close the doors and let her rip. I have a mist coolant system running, so it's blowing air with just a little bit of coolant lubricant to contaminate the tool and to blow away the chips. Once I get the flood coolant system working, I can be a lot more aggressive at cutting. Video should be about 20 minutes long. It's the cycle time for all these operations. If I had a lathe, I could make it a lot faster too. But do with what you have. Circle mill this part. Do love the finish off this 1.5" face mill with carbide inserts. Around 2,500 RPM, 25 inches a minute. 10 inches a minute, excuse me. Sure love having an enclosure now so all the chips stay in one spot, not all over the garage. I can go deeper with this face mill, but 100th hour, 1/10 of an inch is good enough. It takes a few extra passes. And there's my new air compressor. At least I can talk over it. At least I hope I can talk over it. Last pass is a 100th of an inch, 0.01, just to give it a nice surface finish. switch tools. 10-tool tool changer helps, but I can run a lot more if I manually load them. Let's add a little more light. Cutting an 1/8 inch deep and a 30% step over, approximately, 1/2 inch cutter, 3 flute. It's getting a little dull, so I can see a little burring on the edges, but it's not bad. Hopefully that air compressor will turn off soon. There we go. A shorter tool would be a lot more rigid and I could be more aggressive. But this is what I have. So, try to get too aggressive with a long tool, you'll break them. Does a pretty good job for a hobby mill. Amazing how the chips fly off. When the flood coolant system's installed, I won't have chips flying everywhere, but I will have coolant spraying everywhere. But it'll wash the chips away through a filter system and recycle the coolant. This is the slowest operation. Takes the most amount of time. You may end up fast forwarding this and re-recording it or editing the video to cut the time on the video on this. Well, at least 20-minute video isn't too bad. Indexable Carve Smart Vice jaws I've got. I can take this fixture out, 6 months later drop it back in, set the origin and go. It'll always be in the same spot and the vice jaws will line up with each other. Makes it an easy way to make fixtures in the vice that I can repeat and use over and over again. So the original stock was just bandsaw cut, and I used the plate thickness against the jaw vices up on a parallel bar to cut the first side. It does save time, but it also means you can't repeat and put the back in the vise in an accurate position every time. So, not the best way to go. Round stock would have been better. I would have had a lot less roughing to do. Whether I use a lathe to do all the turning and threading and just mill the hex in the square, or round stock in a soft jaw holding round stock. it back in the machine. Especially if I face the end of the round stock and make it nice and square to the rod. This is 7075 T6, so it's a really hard aluminum. Almost cuts like a mild steel. Another reason I can't be quite as aggressive. Kind of like a numerical control router on steroids. They needed to be a strong material because they're going to be an adapter for a large-scale RC car to hold a different brand wheel than the car is normally supposed to have. So this will convert the square drive to a hex drive and hold these alternate wheels. Don't want the threads ripping out. The stock axle will go through the hole and have a nut on it, either Loctited or a nylock. And then there'll be an aluminum nut going on the threaded part we're making here. It would be nice if I could speed it up. Like when I simulate it, I run it much faster in the simulation. It only takes a few seconds to go through all the operations. I've made a CAD model of this machine, including the fourth axis, so I can simulate pretty much anything I want to make and pretend like I'm machining it before I come out here. Planning and prepping and simulating, I still scrap parts, scrap tools, making stupid mistakes. But that's part of learning. At least this time I was able to save the tool and save the block of aluminum, so I didn't eat too much of it up. I had a lot of excess. Haven't lost a part in this batch. Also, the first part didn't quite fit right, so I had to make adjustments in the geometry. It's too loose on the square drive. So I took out the 5 thou of clearance and dropped it down to 2 thou. And now they just slide right on. Won't make any difference on the front wheels of a two-wheel drive buggy, but it will make a difference on the rear drive wheels. You don't want any slop. Alright, we're almost done with this. After it finishes this pass of roughing, it'll do a single pass at full depth to clean up the wall, get rid of any step marks, and make a nice finish, which really is kind of a waste of time since I'm threading it. And I could have bought a die and hand threaded them, or I could have set my lathe spindle up on this and converted this to a lathe, but that takes so much work to do just to convert it, unless I'm doing a whole bunch of parts. This is better for short runs. Just mill them. If for some mysterious reason these become popular and I need to make a bunch of them, I'll probably outsource it to people that have the right machine tools. This could be done on one machine in one setup. If you have a live a mill turn machine, like a Mazak Integrex or something. But that's a lot more money than I can afford on a hobby. Looks like the final pass of roughing. I think my step over is about 30%. 30% of the diameter of the tool, never go past half, and never go past the diameter in depth. Well, you can, but you got to use high-speed machining techniques. There we go. A little bit of howling and vibrating. Harmonics. But that does leave a nice finish. Alright. Time to switch to the thread mill. This is a 3/8 inch thread mill. Single flute. So these threads are M18 by 0.1, kind of an extra fine thread for an 18 millimeter. Typically they're 1 1/4, 1 1/2. These are 1. And that's so we can buy the nice MCD brand nuts that you can use and not have to make them too. I'm a firm believer, if you can buy the part, don't make it. Just make parts that don't exist. Oh, there goes the air compressor again. Keeps my tank at 90 psi to 120. This cycles. And on a lathe, this is only a couple seconds. 1, maybe 2 passes at the most. Everyone I've talked to about outsourcing these parts says, well, how many parts do you want? 100 or 1,000? I tell them, like, maybe a dozen? I'm just not interested in doing small part runs. So you wonder why it's so expensive to have 1 or 2 parts made? This is it. It takes a lot of time. On a hobby machine, you can't just walk away and assume it's going to do everything without a mistake. You need to be here with your hand on the kill switch in case something goes wrong. This is my 4th part that I've made out of 12. And the program's running pretty good, so I felt it was time to videotape it. Down to the last tool. Quarter-inch ball nose end mill. And I'm going to deburr and chamfer the inside hole, the threads on the end, and the back of the hex will round off the sharp corners. Always amazes me how precise this machine is. And it's still not as accurate as the Haas I ran at Boeing. The last one takes a little while. It has a number of passes, probably 6 or 8 passes to go around as it kind of hem stitches down around a cone shape. Every time around it'll drop down a few thousandths more. Every time you see that jog over on the backside, it's actually dropping and moving. That would be it. Now for the real test, to see if the let's see if my net thread's on. Come on. Looks like the threads work. All deburred on both sides, so there's no sharp edges. Thanks for watching.